Hello students, welcome back to my channel. Myself Professor Shubhit Garak. In today's video we are going to know about the absorption, spontaneous emission, stimulatory emission. These are three different ways by which we can change the energy of an atomic system. In first case, the energy of an atomic system is increased. In second and third case, the energy of an atomic system is decreased. Okay. If something is emitting the light, if there is an atom which is emitting the light, then one question comes in our mind that how the light is emitted, how the photon is emitted, and you will get the answer of this question in mind to this video. Okay, so let's start. Let's start with absorption. There are two energy states, E1 and E2. E1 is called as ground state. E2 is called excited state. What is the ground state? Ground state is the energy state which possesses the least amount of energy. There is no energy level present in an atomic system which has less energy than the ground state. The ground state energy is not zero. It is always more than zero. Okay. So it possesses the least amount of energy. And what about the excited state? Excited state is the state which has more energy than the ground state. Any energy state which has more energy than the ground state is called as excited state. Okay, you got that? Excited state and ground state. Okay, let's start. Suppose initially the atom is at the ground state. Atom is at the ground state. Or you can say electron is at the ground state. Okay, electron is at the ground state. And suppose we have to send this electron to the excited state. We have to send the electron to the excited state. To go to the excited state, it will have to get the energy of that state. So it is possible by the photon has energy. There is a photon of energy E2 minus E1 is incident on the electron which is at the ground state. Also equals to the E2 minus E1. So this photon is possessing energy which is exactly equals to the difference between the energies of excited state and ground state. Then what will happen? This photon will be absorbed. By an atomic system or by an atom, and the electron will go to the excited state. This state is called as excited state. Now the atom is excited, electron is excited. So for how long it will be stay there? It will be stay there for around 10 raised to minus 8 seconds, for example. 10 raised to minus 8 seconds. This time is called as lifetime of that excited state. So here the energy is absorbed. Initially electron was there at the ground state. The photon of energy E2 minus E1 incident on it. The photon is absorbed and electron goes to the excited state. In this case, the energy of an atom is increased. And it got energy from the photon. Energy increased by E2 minus E1. Okay, let's study the spontaneous emission. Spontaneous stands for natural, and emission is the process of emitting something, like emitting photon. This is a natural process of emitting photon. This state comes after the absorption, because you see the first diagram of absorption, the electron is at ground state, but in the first diagram of spontaneous emission, electron is at the excited state, and this state comes after the absorption. So after the absorption, electron is found at excited state, and as I said, it will be stay there for 10 raised to minus 8 seconds, finishing the lifetime of the excited state, and that is 10 raised to minus 8 seconds, for example, it will come down to the ground state. So electron comes down to the ground state, and while coming to the ground state, it will have to lose energy. It loses energy in the form of photon. And it has energy E2 minus E1. It has energy E2 minus E1. Photon is emitted. This type of emission is occurred in tube light, in bulb, in sun, any ordinary source of light which emits the light on the basis of this principle, spontaneous emission. Okay. In absorption, photon was absorbed. In spontaneous emission, that photon was emitted. I hope you got what is meant by spontaneous emission. Now, the most important is stimulated emission, because this emission is playing an important role in the production of laser. You might have heard about laser. Let's study. Let's see. Again, this state comes after the absorption. So where will be the electron? The electron will be at the excited state. The electron will be at the excited state. You got that? Again, the excited state has lifetime 10 raised to minus 8 seconds. But it is different in this case. Here, after finishing the lifetime, the electron is going back to the ground state, emitting energy in the form of photon. But here, something new going to happen. Photon is incident on this excited state. Photon is incident on this electron, which is at excited state. That photon is also
the similar
energy E2 minus E1. E2 minus exactly same photon which was incident at the time of absorption. Both are identical. Both are having
similar
energy. Now, there is a chance that electron will go to the upper states, but the energy is not matched. This energy of photon is not matched with the difference with another upper energy state gap. That's why this photon triggers to this electron to come down to the ground state before finishing its lifetime. What is happening here? This electron is not completing the lifetime of the excited state. Before that, it is coming down, because this photon is triggering, this photon is forcing that electron to come down to the ground state. And while coming down to the ground state, this electron, which has already taken one photon, it is emitting that photon in phase with this one. So at the end we are getting two photons. Both are having energy E2 minus E1. Each one is having energy E2 minus E1. E2 minus E1. E2 minus E1. So here we got two photons. You can say this is an amplification of photons. One incident, we got two. One incident, we got two, but it is not in case, because while going to the excited state, that atom is already taken one photon. These two photons are exactly in phase with each other, so we can say these photons are coherent, and because of that, this is called laser. This photon is nothing but laser. So here we got the laser, in which type of emission? Stimulatory emission. We got two photons in phase with each other, and laser is artificial emission. It is not natural process. Emission is there by force. I hope you got all these three things by which we can change the energy of an atomic system. In absorption, the energy of an atomic system is increased. In spontaneous emission, energy is decreased with the emission of photon naturally. In stimulatory emission, energy is also decreased of an atomic system. It decreases in the form of photon, but the emission is forcefully happen. And here we got two photons in phase with each other. Both the photons are coherent, and we call it laser. Thank you very much for watching.